Welcome back, everyone, and welcome to week 11 of Marketing 2700 Design and Product Development. I'm Brad Scheller, and we are deep into the home stretch now. And this week we tackle something that separates the great product designers from everyone else, actually building things at scale, fast, without destroying your budget or your team. So this week's theme is extreme manufacturing, the methodology that has powered SpaceX, Tesla, and Joe Justice's open source car company, WIKISPEED. We're going to learn what happens when you take agile thinking, sprints, iteration, minimal waste, and apply it to physical hardware. So buckle up. This week has a lot in it, including your demo day prototype video. So let's go. So here we go. Here's your week at a glance. 5 buckets: watch, read, case discussion, quiz, and deliver. So for watching, you're going to start with the kickoff video here, and then you're going to watch a video about Joe Justice's extreme method. You're going to look at SpaceX manufacturing video and also a Tesla manufacturing video. And as a bonus, you're going to look at crossing the chasm. It's only about 12 minutes, but it's a really important concept in marketing. And it tells you basically what you need to do to succeed on the long term. For reading, you're going to read chapters 13, 14, and 15, and also the Joe Justice methodology. Now, I don't like to give out a lot of reading all the time. So in the assignment, I put a little secret about how you can get through this very quickly. So if you'll read the assignment, you'll save yourself some time. Then in the case, your case this week is Tesla Act 1, and it is a case about whether Tesla is truly a disruptor or something else entirely. Be interested in seeing your comments in the discussion. Next, for the quiz, you're going to take a quiz. It's going to cover chapter 13. And then the big one, this Sunday, it's demo day. And this, again, is 7.5% of your grade. So it's a big chunk to get you that high score. Your functional prototype design video is due, and the prototype has to work. Don't sleep on this. I'll walk you through entirely exactly what's expected in a few slides, and I will be available Thursday if you want to meet during our Zoom meeting to discuss and get feedback on your video. So here's a mental model for this week. 2 lenses side by side. On the left, extreme manufacturing. The core idea is deceptively simple. Take everything you've heard or know about agile software development and apply it to physical hardware. 1-week sprints, small self-organizing teams, working testable hardware at the end of every sprint, not documentation, not plans, not PowerPoints, actual hardware. Joe Justice applied this to WIKISPEED, where a small volunteer team built a 100 mile per gallon car that passed European safety standards in just 3 months. 3 months. Traditional automobile development takes 3 to 5 years. SpaceX took it even further. Their fly until it fails approach, launching rockets, crashing them, learning from the data, and then flying again, is extreme manufacturing at massive scale. Now on the right is design for manufacturability, or DFM. The comparison discipline from chapter 13 is very different. Before you can manufacture fast, you have to design for speed. Simplicity, simplify your part count, standardize your materials, moderate your subsystems, and design with the end manufacturing process in mind from day one. The companies that win manufacturing think about DFM from the first sketch, not after the design is frozen. Now to this week's case, it's actually one of the best ones we've used all semester. Tesla Act 1, Disruptor or Disrupted. It puts you inside Tesla in 2015. The Model S is winning every car award. The Model X is about to launch. The Model 3 is in planning. But the company is burning cash. Critics are calling it the next Edsel. Now, the case raises three core tensions I want you sitting with as you read them. First, is Tesla actually disruptive? Clayton Christensen, the man who literally invented disruption theory, said publicly that Tesla is not disruptive. And of course, Elon Musk was furious. Your discussion this week needs to resolve this. I want you to take a position and defend it using or abusing Christensen's actual criteria. Second, the manufacturing paradox. Tesla's factory was toured by executives from legacy automakers who reportedly called it inefficient. Yet Tesla outpaced everyone. Why? Because they weren't optimizing for traditional efficiency, they were optimizing for learning speed. That is the XM principle in action. Third, the doing too much trap. Tesla makes vehicles, batteries, gigafactories, superchargers, power walls, and it owns its own dealerships. Is that too much? Or is it going to lead to failure? What's different? That's your analytical challenge. Also this week, we covered Jeffrey Moore's technology adoption lifecycle that we mentioned earlier in the course. I think you saw a video about last week, and his book, Crossing the Chasm, where most products die. Let's apply that trademark framework to Tesla. The Roadster served the innovators, 2.9% of the market, wealthy tech enthusiasts who would drive a prototype just to be first. The Model S captured early adopters, high-income professionals who valued the performance and the statement. But then comes the chasm. The early majority doesn't care about it or about being first. They care about reliability, charging infrastructure, service networks, and price. That's a completely different buyer with completely different needs. The Model 3 was Tesla's attempt to cross that chasm. And here's the insight I want you to carry into your case discussion. Tesla's manufacturing strategy is its chasm crossing strategy. The Gigafactory exists to bring down battery costs enough to make the Model 3 affordable. The supercharger network exists to eliminate range anxiety. The ability to have their own dealerships deals with the anxiety of getting service. Vertical integration exists to control quality and speed at scale. The manufacturing is not separate from the go-to-market strategy. It is the go-to-market strategy. So based on that case, your case discussion this week is worth 2 points. And the prompt is deliberate. Is Tesla a true disruptor? Now, I've given you 4 lenses to choose from, and I want you to pick at least 2 of them to discuss in your debate. First, Christensen's original disruption framework. Apply his 3 criteria directly to Tesla and tell me whether it passes or fails. The teaching note will help, but I want your original thinking, not a summary. Second, the ecosystems or system lens. One of the most powerful moves in this case is zooming out from the product to the entire system. Map every node Tesla needs to win. Batteries, charging, service, manufacturing, regulatory support. Which nodes are hardest to establish? Which require Tesla to go it alone? That analysis reveals the true risk. Third, architectural innovation. Henderson and Clark's framework tells us that incumbent firms often fail not because they lack resources, but because a new architecture destroys the knowledge embedded in their existing organization. Tesla's ground-up battery architecture is exactly this kind of disruption. And fourth, the XM manufacturing lens, which ties directly to our week's theme. Evaluate Tesla's factory decisions as an XM practitioner. What did they optimize for? Was it efficiency or learning? So again, pick 2, make an argument, engage with at least 2 classmates. All right, so now let's talk demo day. This is a major deliverable, 7.5 of your final grade. Your functional prototype design video is due this week, and I want to be crystal clear about what it needs to contain. Your prototype must actually function. Not a static model, not a PowerPoint presentation, not a 3D rendering, something that works, something that you can show in motion, that does the thing it's supposed to do. If it only partially works, film the parts that do work and narrate the rest. But I need to see function. Walk me through your design choices and trade-offs. Why did you make the decisions you made? What did you try that didn't work? That narrative of failure and adaptation is part of your demonstration. Show me how user or stakeholder feedback shaped your design. If something changed because of a prototype test, tell me about that story. Apply at least one DFM principle explicitly. Name it, show me where you applied it in the prototype, and tell me what you would do differently if you were building this for production scale. Every team member should appear in the camera. This is a group effort, and I want to see full team participation. Additionally, you are responsible for watching every other group's video and leaving substantive peer feedback in the discussion, and that's worth 2 points. There's not that many other teams to watch, so I expect everyone to watch that. And don't forget the Notebook LM check-in. 1 point for importing this week's material and sharing a screenshot or of a meaningful exchange. More importantly, I want everyone to send me to my email in Canvas the link to their Notebook LM so I can look at their notebook and give you the point. Not everyone did this last week. Now, here's where I want to connect the dots for you, because this week isn't just about studying Tesla. It's about applying what Tesla did to your prototype and to your bag of tricks. Look at this table. On the left, this is what Tesla actually did. On the right, it's the equivalent principle for your team this week. So, Tesla designed from the ground up around the battery, not around convention. You should design around the core user job to be done, not around what's easiest to build. Also, Tesla acquired an old factory at 4 cents on the dollar and made it work. You don't have the resources, but the principle is the same. Be creative with what you have, 3D print, laser cut, prototype fast with whatever's available. Speed matters more than polish right now. Also, Tesla builds multifunction robots. You should build for modularity, components that can be swapped without rebuilding everything. And Tesla famously ships software updates that improve the car even after you bought it. Now, I want to see your version 2 plans in your demo day video. What would iteration 2 look like? That thinking is what separates a product designer from someone who just builds things. So, I want to leave you this week with something Musk said that reframes everything. The factory is the product, not the car, not the software, the factory. Because a factory that can learn faster, iterate faster, and produce higher quality at lower cost, that factory is the competitive advantage. That's what extreme manufacturing is about. That's why the Gigafactory matters. That's why Tesla's vertical integration matters. And that's why your prototype process this week matters too. 3 things I want from you this week. 1, build it. Demo day is now. Your prototype must function. No more planning. Ship. 2, argue it. Take a real position on whether Tesla is a disruptor or not. Not it depends or something mealy mouthed. Take a real position. Defend it with real frameworks. And 3, connect it. Start seeing how manufacturing strategy and marketing strategy are 2 sides of the same coin. When you scale your own product concept someday, you'll understand why. So, I'll see you on your video. So make it work and make it matter. Have a great week.